Hello, everybody. My name is Tim, and today I'm going to talk about AI-driven engineering quality. So, a little bit about myself. I'm working in the IT industry for over 5 years. I've been building games most of my career. For the first 3 years, I worked as a software engineer, and I worked on apps that have over 10 million users. And for the past 2 years, I switched to product management and I worked on an app that has over 800,000 users. And on average, the apps that I shipped, they have 200,000 plus users. The problem I've been facing for my whole career is the wrong time estimation of the delivery time, how long it's going to take the feature for the engineering team to build and put into production. About half a year ago, I realized that AI is good enough to estimate the time, and I decided to work on the implementation of AI into discovery and engineering workflows. So the solution that I've built internally in the company I work at is a predictive pipeline that estimates delivery time. So before the coding is done, the discovery team come to meet a delivery team and they can discuss the time it's going to take for the feature to be coded and delivered, put into production. So before we could only use engineers' knowledge to estimate it and also the past Jira sprints to correct their estimation, but now we can use AI to estimate these discovery documents. And also this tools helps developers because when developer commits something, the AI gives feedback on every commit and every PR. And if engineers find the information useful, he doesn't have to wait for the review by another engineer. He can just work on the AI review and make changes to the code and commit again. So the architecture is the first step is feature extraction. We provide the Git history to AI model that then analyzes this. And also it uses RAG retrieval to see the past work and if it can relate the new feature to one of the previous features, then the estimation is going to be better. Then LLM analysis step, where it reasons about complexity, risk factors, and then it outputs the key findings that are the time estimation with confidence, risk scores, and actionable recommendations. For this demo, I built the pipeline from scratch, and it's not production ready. So if you want to use this tool that I'm talking about, you can't put it into production straight away. You'll have to build on it to make it production ready. I didn't use the tool that we use in the company. And also the repository, I've participated in Hackathon 2 months ago, and I decided to take this Hackathon repository as an example to deliver this demo. The project I worked on, it is made out of 3 different repositories, the Backend, the Frontend, and the smart contract. It's what was a Web3 hackathon. Studied code analysis. The first step, AI gives us the number of files, lines of code, complexity, and risk score of each of these repositories. So the backend is an SJS and Postgres, and it has a good architecture and the risk is very low. The front end, I use Cocoa game engine, and in its environment, you have to manually connect UI to scripts and do something on the scene. And AI is not very good at understanding that, so the risk is higher. For example, if I used React as a front end, then it would be 15, 20 points lower, probably if the code was written with a good architecture and etc. So the next step is when discovery team comes to you and asks you how long it's going to take to build this feature. So instead of talking to developers and going to meetings, product manager, like marketing product manager, can use this, and they just write down the task they want, like the feature that they want the delivery team to deliver. And then AI finds similar past work, analyzes it, and gives like the estimated time. Then complexity, so moderate complexity, because it involves API, backend, frontend, and also it advises here the query optimization. Then the risk, it's not a high risk. Then this reg for retrieval of previous features that are somewhat similar, and some recommendations. So that's the first part of it. And now we are moving on to the second part, is the code review. For example, like this commit with NFT service, I'm not going to go through the code. Again, at the end of the presentation, I have links. You can have a look at it. But yeah, it's not very well written. I used actually some AI to write it, and now AI is running the analysis. It reviews the code, and here are the insights. So risk score is high and quality is low. Changes are needed. Here is the summary. We have critical security issues and lots of warnings. So in production, if AI score is higher than 50% or quality is lower than 50%, then the team leads, they get notification, and also the stakeholders, they know about it, and they're going to ask about it during the demo of the feature. So engineer is likely go and work more on this feature, but maybe 0.1% of the time, around like that certainty, AI gets something wrong. And if engineer actually proves that AI made a mistake, then can go on with the feature and just ignore AI. Then we'll have to fine-tune the AI so it doesn't make this mistake again. But it is 100% worth it, because 99.9% of the time AI gets things right. And after we train it more and more, it gets even better accuracy. So this is pretty accurate. Let's go on to the next example. So here is the bad code example. I'm just going to run it for AI to analyze. And meanwhile, we can have a look. It has like secret key exposed, hard-coded, then no input validation, then like command injection, auth bypass. So lots of issues with this code. And yeah, AI runs the analysis and say 100% risk. It's unsafe for production. It's very low quality. Changes needed, obviously. Critical warnings, security. Yeah, so if you get this code into production, it's going to be a nightmare. Yeah, also, as I mentioned before, we can compare the AI estimations to actual time it took to deliver the feature. So it's in this demo, it's simple. It filters the 8-hour gaps. So during the nighttime, when developer was sleeping, it kind of filters these gaps, and then it counts everything else as the working time. And based on this, and based on like commits, and when the work on the feature was stopped, it can give pretty accurate estimate. And as you can see, it gets everything right, apart from backend setup. Yeah, but because it was done with the help of AI, it went much faster. So to summarize what we built a tool that uses AI to extract features from Git history. Then it can analyze the code. It uses reg to retrieve the previous features and compare them to the new feature. It uses estimation, LLM-powered estimation, and code review. It detects code vulnerability. And yeah, that's about it. In terms of results, when the team started using this tool, we got delivery estimates up to 80% from 60%, so that's a lot. And we can catch security issues before merge. PMs can prioritize tasks themselves without doing long meetings with delivery teams. Also, it helps engineers to work because they can see something that AI advises that's probably they didn't think about, and it saves time of other engineers who have to review this code, because in general PRs, they became much better after this tool was used. And in terms of tech stack, we, for this demo, I used Python, Fast API, ChromaDB, and Cloud API. And we use pretty much the same thing in production. Yeah, it's just the code quality and security is better in our production than in this demo, but the bases are the same. So thank you very much. Here you can see GitHub repository of this demo. You can run it with git clone, just copy and paste this inside your terminal. But also you'll have to use the Cloud API key or OpenRouter API key. Otherwise, the LLM is not going to work. Thank you so much for your time. I hope it was useful. Bye.